In this question, we're told that x is directly proportional to the square of y, and y is directly proportional to the cube of z. We're also told that z is equal to 2 when x is equal to 32, and we need to find a formula for x in terms of z. Now, if x is directly proportional to the square of y, we can say that x is equal to some constants multiplied by the square of y. And so we can say that x is equal to a y squared, where we can see that x is equal to some constant, which we're going to call a, multiplied by the square of y, y squared. So that's equation 1. Now we can then have equation 2, explaining how y is directly proportional to the cube of z. And we can do the same thing here. If y is directly proportional to the cube of z, we can say that y is equal to some other constants multiplied by the cube of z. And so y is equal to b z cubed. Now we're using a different constant, b, because the constant of proportionality for both equations won't necessarily be the same. And so we have two unknowns, a and b, but we'll be able to cancel them out soon. We now have our two equations, x is equal to ay squared, and y is equal to bz cubed. Now to find a formula for x in terms of z, we want to make x a subject and we want to get rid of the y's. Now how can we get rid of the y's? Well, we can substitute the values of y into the new equation. And so if x is equal to ay squared, and we know that y is equal to bz cubed, we can get rid of y by placing the value of y inside the formula for x. X is equal to ay squared. And so we already know the value of y, which is bz cubed, but we can say that y squared would be equal to this whole thing squared, which is equal to bz cubed all squared, and using our index laws, bz cubed all squared would be equal to b squared, and then z cubed all squared, and the second index law that we're going to use is that z to the power of 3 all to the power of 2 is equal to z to the power of 3 times 2, which is z to the power of 6. And so we can say that y squared is equal to b squared z to the power of 6. We can now substitute this in to equation 1. If x is equal to ay squared, and y squared is equal to b squared z to the power of 6, we can say that x is equal to a b squared z to the power of 6. But now we still have these two unknowns, a and b, and we want to get rid of them, because we just want a formula for x in terms of z. And so we're going to use the fact that z is equal to 2 when x is equal to 32. So we know that x is 32, a, b squared stay the same, and z is equal to 2, so we have 2 to the power of 6. Now we know that 2 to the power of 6 is equal to 64, and so 32 is equal to ab squared multiplied by 64. Now it's easy to get confused here and to think, well, we have two unknowns, what's the value of a and what's the value of b? But now we're just interested in finding the constant of proportionality between x and z. And so ab squared is a times b times b. But since a and b are both constants anyway, this entire thing can be merged into a constant of its own, and so we can just call it a different constant. We want to find this constant in order to find a formula for x in terms of z. And so if we know that 32 is equal to ab squared multiplied by 64, we can say that ab squared is equal to 32 divided by 64, which is equal to 1/2. And so bringing it back to this equation here, where we said that x equals ab squared z to the power of 6, we now know that ab squared is equal to 1/2. And so we can say that x is equal to 1/2 multiplied by z to the power of 6, which is our final answer, because we've now found a formula for x in terms of z. So we can say that x is equal to 1/2 z to the power of 6. Now this question is worth 4 marks. We get our first mark for setting up our two equations, x is equal to ay squared and y is equal to bz cubed. We get the second mark for eliminating y by finding the value of y squared and substituting this in to our first equation. We get the third mark for using the fact that x is equal to 32 and z is equal to 2 in order to find the constant proportionality between x and z. And we get the fourth and final mark for finding that this constant is equal to 1/2, and so we can therefore say that x is equal to 1/2 multiplied by z to the power of 6, allowing us to get the full 4 marks needed in this question.